Hello and welcome back. In this episode, we are going to look at a concept called LRM, which is slightly different from an LLM. So, to explain what a LRM can do for us, what I'm going to do is give you an example and maybe we can figure out how it helps us. So, an engineer once posted a question on an online forum. Why is my program crashing when I run this particular API request? And then he ran the same question through two different AI systems. The first one kind of responded immediately within seconds. It produced a clear, coherent answer. Very beautifully phrased, confident, smooth, everything. The engineer almost took the code and started to fix his program. But then he realized that response was actually introducing an error. What could it be and why? The more he thought about it, he could see that there was actually a new error that was being introduced. Then he looked at the second system. This took much longer to respond. It paused, it examined the stack trace, maybe mapped the flow of data, and finally it explained the real issue, an edge case mismatch in the data type. So this is kind of explains how the two different AI systems are different. One spoke like an expert, the other one thought like an expert. That's the main difference between LLMs and LRMs. So that gap, that space between being fluent and being able to reason is what LLM and LRMs are different in. So let's look at it. So generative AI kind of arrived in our lives through large language models. We used a lot of these chatbot systems, we wrote essays, we did our homework through that, a lot of different things. They basically predict the next token and they're extremely good at that. Their power kind of lies in recognizing patterns, not constructing logic. So this makes them extraordinarily good at sounding like a human because humans also do that. But prediction alone is very brittle. What I mean is, in any task where accuracy depends on a careful sequence of steps, like formal logic, mathematics, scientific analysis, LLMs often take shortcuts. It may sound correct, it may not be the best answer. So they hallucinate to find some of the missing links. So, like a reflexive student answering before fully thinking, they can be brilliant one moment, but they could be disastrously wrong when it requires a lot of thinking. So, reflex is fast, reflex is fluent, but reflex is not reasoning. So, that's where LRMs come in. So, there is a gradual shift towards deliberation. So, let's look at what gives rise to these large reasoning models. LRMs introduce an internal deliberation mechanism, a private reasoning workspace where the model examines the problem before generating an answer. The difference is huge. While an LLM produces the most probable continuation, an LRM constructs a plan. It evaluates potential approaches, tests a hypothesis. Only after this inner process does it decide what to say. So, in other words, the LLM reacts, the LRM considers. So, this deliberate architecture makes LRMs feel less like chatbots and more like problem solving engines. So, let's look a little bit into the mind of an LRM. A large reasoning model operates through a mechanism often called as an internal chain of thought. It is very similar to how we human thinks. We look at different options in our brain before we say something. At least we want to. So, when confronted with a challenging question, this system doesn't jump to the first answer. Instead, it branches into multiple reasoning paths, different interpretations, assumptions, strategies. All of these branches may compete, they may refine each other, or they could be discarded entirely. So this process, invisible to the user, leads to the answer that is structurally sound rather than just being stylistically correct. So while an LLM may generate a elegant hallucination, an LRM must generate a very coherent derivation. So the distinction between guessing the next sentence and deriving the next step is what separates this surface level intelligence from true logical competence. Now let's look at why reasoning matters. As AI becomes embedded in fields that demand, rigor in finance, engineering, the margin of error shrinks dramatically. A fabricated number in a financial audit or a missing step in an argument can cause real cascading damage. This is where LRMs really shine. Their architecture is built to survive complexity. They understand that one mistake in this step can collapse the entire solution in step 9 or step 10 somewhere. So they respect the fragility of this logic and they do not rush. So let's look at how expensive it is to do or build a system that can inspect its own solutions. So deeper reasoning is not free. Every extra internal step, every hypothesis tested consumes more GPU memory, more processing power, more time. Therefore, it is more costly. So for the first time, AI systems introduce the concept of an inference budget. Yes, inference has a cost and there is a budget. This is the amount of mental effort the model is allowed to use. A simple writing prompt may need only a minimal budget producing a quick response, but a complex puzzle may trigger a larger budget, enabling branching, reasoning, consistency, and even internal voting among competing answers. So, this creates a sliding scale of intelligence. The more computation you allow, the more capable the reasoning becomes. It also forces developers and organizations to ask a new, very uncomfortable question: when is accuracy worth the price? Right? So let's look at how LRMs are built. We had looked at LLMs, we had looked at foundation models. The foundation of LRM is still a large language model. The foundation is still a LLM. This is an engine that is rich with linguistic knowledge, pattern recognition, and all the basics that we had learned. But the transformation into a reasoning system happens through specialized training. Instead of absorbing more web data, this model is exposed to carefully curated problems, multi-step mathematics, logic grids, all of those things. So crucially, each of this problem includes not only the correct answer, but the complete chain of thought behind it. So over time, the model begins to internalize this discipline of reasoning itself. It learns structure, consistency. It learns not just to answer questions, but to solve them. So from prediction to planning, as LRMs advance, they are surpassing LLMs on nearly every benchmark. So this is kind of the measure of true intelligence. So this shift feels similar to watching a child who once memorized answers suddenly learning how to show their work, how to evaluate their own work and put forth their best work. So LLMs revolutionized how we write. LRMs will revolutionize how we think. They represent a transition from expressive intelligence to analytical intelligence. So, this transition is not merely technical, it kind of reshapes our relationship with machines. We are no longer designing systems that imitate the surface of human speech. We are building systems that mirror the structure of human thought itself. So, every major leap in human progress has been accompanied by an expansion in our tools of thinking. Once we learned writing, we were able to think more. Once we learned mathematics, we did more. All of this amplified our cognitive reach. So the emergence of large reasoning models, LRMs, this represents the next such frontier. These systems are not simply faster or more articulate, they are more deliberate. They reflect in code the inner mechanics of human reasoning. And as they move from reflex to reflection, from prediction to planning, a new era begins, one in which machines do not merely assist our tasks but participate in our thinking. It is the moment where artificial intelligence becomes not just a tool of expression but a partner in our understanding. So, in that partnership, the future of intelligence, human and machine, will be rewritten. That's all I wanted to talk about in this episode. Just a quick overview of what LRMs are. We will do a little more deeper dive into how an LRM is built, how is the cognition layer built. We will go into all of those things much later in the series. But in the first few episodes, I wanted you to understand that there are newer models coming which are getting us closer and closer to intelligence. With that, I will end this episode. Thank you for watching and do come back for more.